Hello, my dear students. In this lecture, let us see the different psychrometric processes which are carried out on the atmospheric air according to the required conditioning. Me, Dr. Shrikala from the Department of Mechanical Engineering, Global Academy of Technology. Now, let us see what are the different processes which can be carried out in order to obtain the required comfort at the required location. The first process we'll see. Before going to the process, let us consider the psychrometric chart. In the psychrometric chart, let us consider a certain position here. Now, the first process is sensible heating. Sensible heating means this is carried out in the regions where the temperature is very less. This is simply rising the temperature of the atmosphere or the closed enclosure where we need the comfort. Wherein in this case only the dry bulb temperature is increased, keeping the humidity constant. The second case is sensible cooling. Sensible cooling means just reducing the temperature, dry bulb temperature, without changing the moisture level in the air. The next one is humidification. Humidification means keeping the dry bulb temperature constant. We are just humidifying the air. That means increasing the moisture content in the air. Normally, humidification will be done in the locations where the weather is dry. Next is dehumidification. Dehumidification is done in the regions wherein the locations are or where the regions where we need to dehumidify is located in sea level. That means Chennai, Bombay, etc. Wherein dehumidification, the temperature is kept constant and only the moisture level in the air is reduced. The next is heating and humidification. Here, this is used normally in winter air conditioning systems, wherein the temperature during winter season, temperature will be very less, especially in the regions like Rajasthan and during winter season, wherein the temperature will be very low, somewhere around 2 degrees, 1 degrees, etc. And also the weather conditions will be dry since it is a desert region. So in such cases, we need to heat initially and then also humidify for required comfort. The next is cooling and dehumidifying. This is the locations, as I said, in the sea level in the summer. That means this is summer air conditioning, wherein during summer region the temperature will be very hot, and especially when the regions near sea level, it will be there will be lot of moisture content in the air, so it has to be dehumidified or reduce the humidity in the air to obtain the comfort condition. The next is evaporative cooling. In the evaporating cooling, you are humidifying the air, that means increasing the humidity as well as it is cooling. The last one is chemical dehumidification. Normally, chemical dehumidification, chemical industries where dehumidification is said to be done in order to, especially in storages, wherein the dehumidification has to be done in order to avoid the fungus or in order to store for longer time. Now, slowly we will get into each of these cases and we'll try to understand each case. Now, first case is sensible heating and cooling. Sensible heating means just addition of heat. Cooling means removal of the heat. This is without changing the moisture level in the air. Now consider a channel wherein the heating coil is placed. Let the air blows over the heating coil. During this time, let the temperature be initially dry bulb temperature at the entry be TDB1 and at the exit be TDB2. Air, as it passes over the heating coil, takes the heat and rises the temperature of the dry bulb temperature. So TDB2 will be higher than the inlet temperature. If you come across the specific humidity, as I said in my previous slide, where it says the humidity remains constant during sensible heating. Now, when the temperature is increased, the capacity to hold the moisture level will also increase. That's why, so your phi to the relative humidity comes down compared to the inlet. Let us see here in the psychrometric chart. Let the condition 1 be the inlet of the before entering the heating coil. So once it enters the heating coil, the temperature increases. The dry bulb temperature increases. Let phi 1 be the condition at relative humidity here. As you go towards right, the relative humidity goes on reducing, right? So your two condition wherein the dry bulb temperature increases whereas the relative humidity reduces. This condition 2 is at the exiting of the heating coil. Let H1 is measured like this. H1 be the enthalpy at the inlet and H2 be the enthalpy at the exit. Next, the point number 3 is nothing but the temperature of the heating coil. Always the heating coil temperature will be higher than the air coming out because the air cannot reach the heating coil temperature when it passes over it. So the air temperature at the exit will always be less than the heater coil temperature, and let that be temperature be TDB3 and the enthalpy be H3. So with this, we need to also note down what is the bypass factor, and that will be equal to difference in the air and the heating coil temperature, that is TDB3 minus TDB2 divided by difference in the heating coil and the inlet air temperature, TDB3 minus TDB1. Now, let's see the sensible cooling. Sensible cooling means cooling of the air without increasing the specific humidity. So, let the condition of the air be 1 at the inlet here. Cooling means it has to go in the left side. That means the dry bulb temperature should reduce. So, initially dry bulb temperature is TDB1. So, it has reduced to TDB2. So what is 3? 3, as we said already, it is the coil temperature. Also we can see this coil, the air coming out of the cooling coil will not reach the cooling coil temperature. Slightly it will be below the cooling coil temperature. So let phi 1, as the air cools down, the relative humidity increases. Right, we can see here these are the curved lines which come across will be the relative humidity lines, and relative humidity reduces. Okay, now let's see what is the bypass factor here. It is nothing but again difference in the coil temperature and the air coming out. This temperature difference divided by the difference between the coil and the inlet air temperature. Now, let's see the other process, the humidification and dehumidification process. Humidification means it is simply humidifying the air. That means adding moisture content to the air by passing the air over the stream of water. Wherein when you increase without increasing the dry bulb temperature, that means only the air has to absorb the water particles and it has to just evaporate. So let 1 be the condition at the inlet, and when it absorbs the moisture content, it has to gone to 2. So naturally the specific humidity is increased from omega 1 to omega 2, and also the relative humidity also increases from phi 1 to phi 2. That is, here it is only humidification without increasing or reducing the dry bulb temperature. That means what is this heat? The heat which is used or which involves in evaporation, that is, this is nothing but the latent heat. Similarly, coming to the dehumidification, dehumidification means you are reducing the moisture in the air. That means you are cooling the air in such a way that only the dry bulb temperature remains same, only the latent heat is released by reducing the vapor humidity from omega 1 to omega 2. Similarly, the relative humidity also reduces from phi 1 to phi 2. So as such, as I said, H1 and H2 will be the enthalpies of the at two locations, 1 and 2. Practically, this humidification and dehumidification is not possible. So always it is accompanied by heating and cooling, or heating or cooling. Now, let's go to the next case, heating and humidification. So that means initially, first you have a heater coil air which is cold. It should be initially the air is at cold condition. It is passed over the heating coil. So what happens? The heating coil means it is sensible heat. Only the dry bulb temperature increases without changing any the moisture content in the air. Then this air, let us see here, is passed over the humidifier where it gets humidified. That means the specific humidity increases at that temperature A. So let us see that representation here. Now let us see the first case wherein 1 to A, it is getting heated. Only the air is getting heated. So let initially be TDB1, dry bulb temperature at 1. So only heating means the dry bulb temperature increases up to A, keeping the specific humidity constant. Then it is humidified. Humidified means keeping the bulb temperature constant, only the water particles will be sprayed over the hot air. So once the water particles are sprayed, these water particles takes the heat from the air and gets evaporated. So this evaporated air mixes with the dry air and increases the humidity of the air. So let 2 be the humidity of the air at the exit. So specific humidity. So that is represented by this line. So H1 be the enthalpy at the inlet and H2 be the enthalpy at the exit. Okay, so this is generally used in winter air conditioning systems. Then we need to come across one more factor known as sensible heat. What is sensible heat factor? Sensible heat factor is nothing but the ratio of sensible heat to the total heat. So sensible heat means what? So increasing only the dry bulb temperature without altering the moisture content, that is sensible heat. So what is the increase in sensible heat? HA minus H1 is the sensible heat. Next is the total divided by total heat. So total heat includes the sensible heat plus latent heat will be the total heat. So sensible heat is heating from 1 to A, that is HA minus H1 divided by HA minus H1 sensible heat plus the latent heat. Latent heat, that means you are humidifying means latent heat. So H2 minus HA is the latent heat. So if you cancel this HA, you will get the HA minus H1 divided by H2 minus H1 is the sensible heat factor. So you can see here part 1 to A is sensible heating and A to 2 is humidification. Now, next is cooling and dehumidification. So cooling means instead of passing the air over the heating coil, we are passing the air over the cooling coil. So initially, the air temperature will be very high. So this process, cooling and dehumidification, is done in two ways. First, initially, it will be air gets cooled. So air gets cooled means the air initially at higher temperature, but dry bulb temperature reduces, right? So once it reduces, it reaches the dew point. This goes on increasing the moisture content. So what happens is, it will be once the air gets cooled, it will be unable to hold the water particles. So what happens further? So initially air just gets cooled, but further, as the air flows over the coil, the air will be so cold that it will be unable to hold the water particles. So what happens? It condenses into water and the moisture content in the air reduces. So once the moisture content in the air reduces, the specific humidity omega 1, which was initially there, reduces to omega 2. That means here initially, so the once it passes a cooling coil, initially first part only the air gets cooled. In the second part, it will be, it would have reached the dew point temperature and unable to hold the water particles in it. So it starts condensing, and since the water gets condensed, the moisture content reduces, and so the omega 2 will be less than omega 1. So this is represented by the process 1 to 2. So naturally, the dry bulb temperature also reduces, and the omega 2 will also, that is dehumidified as well as cooled. This is used in summer air conditioning system, wherein we need to first cool the air, also we need to dehumidify the air. Again, we'll write the sensible heat factor. Sensible heat factor will be equal to ratio of sensible heat to total heat. Sensible heat is nothing but 1 to A. Sensible heat means it is just reducing the dry bulb temperature without altering the moisture. Next is the latent heat, keeping the dry bulb temperature constant, only altering the moisture content. That means the water gets it gets condensed and reduces the moisture level. So that means you are releasing the latent heat. That is, latent heat will be HA minus H2. So it will be equal to H1 minus HA divided by H1 minus H2 will be the sensible heat factor. Now next case is evaporative cooling. What do you mean by evaporating cooling? That means here it is simply, instead of passing over the heater coil, you are just humidifying the air. Hot air is humidified and then it is made to cool. A simple example is the mud pot which we use during summer season. Since it is porous, the water particles inside it comes out and just gets uh, gets onto the surface of the what do you call, the vessel, the mud vessel. Once it comes to the surface, since the temperature outside is very hot, it takes the heat and this water gets evaporated. Once the water gets evaporated, the mud pot gets cooled. So naturally, the heat transfer here much will be only the latent heat which comes into factor. Hence, the enthalpy remains constant during this process. So this occurs at initially at condition 1, dry bulb temperature. So as it gets cooled, the dry bulb temperature reduces with higher relative humidity. Also, the omega 2, the specific humidity of the water increases, whereas the dry bulb temperature reduces. Normally, this is used in desert region, wherein the principle, mainly the what latent heat of vaporization is the principle behind this, wherein the wet bulb temperature remains constant and is also used in air conditioning calculations. The last one is the adiabatic mixing of air streams. Now consider two air streams which are mixed adiabatically in an which that means in a chamber, adiabatic chamber. That means, what do you mean by adiabatic chamber? That means the whatever is the heat content, it remains same. That means no heat is lost from the walls of the chamber. It is just simply the two streams at different characteristics just getting combined in to single stream. Here during this mixing process, there will be no changes in the kinetic and the potential energies. Now, writing the mass balance, we'll get, so MA1 omega 1. See, now consider here point number 1. MA1 omega 1. Let 1 be the stream 1 condition wherein the H1 is the enthalpy and omega 1 is the specific humidity and TDB1 be the dry bulb temperature. Next, coming to the point 2 wherein let that stream be at temperature TDB2 and having the humidity omega 2 and H2 be the enthalpy of that stream. Now, if we just write the mass balance, it is Ma1 omega 1 plus Ma2 omega 2 will be equal to Ma3 omega 3. And if we write the energy balance, it will be Ma1 H1 plus Ma2 H2 will be Ma3 H3. If we try to eliminate this Ma3, because since Ma3 will be equal to Ma1, Ma2, so if we try to eliminate and take the ratios, we'll get the omega 2 minus omega 3 divided by omega 3 minus omega 1. Similarly, H2 minus H3 divided by H2 minus H3 minus H1. Since these ratios are same, so when two air streams are mixed adiabatically, the final state of the stream will lie on the same line which is joining the conditions or the states of these two streams. So 1 to 2 is the line joining the two streams. The final condition of the stream will lie on the same stream. So this is the most important conclusion during the adiabatic mixing. Thank you.